The world is running on code, billions upon billions of lines of programming instructions, consuming untold amounts of energy. But hidden beneath the layers of abstraction lies a secret, a forgotten art, low-level programming, which is a key to a more efficient digital world. Inefficient code isn't just a digital problem, it's an environmental one. Every wasted line of code demands more energy, straining our hydro dams and depleting precious resources. These silent power drains are pushing our grids to the limit, threatening the very foundations of our sustainable future. This isn't just about technology, it's about us, every person on Earth. Our daily lives are intertwined with the digital world, and inefficient code is silently impacting our development, our economies, and our shared future. Planet Earth feels the strain. As energy consumption soars, so do the challenges we face. Increased carbon emissions from data centers, electronic waste from rapid tech turnover, all intensified by the imperceptible cost of inefficient code. Imagine a world where a child's simple act of drinking fresh water is threatened by the digital inefficiencies we overlook. It's a stark reminder that our actions today shape tomorrow's reality. Let's rethink our code, optimize our systems, and secure a sustainable future for all. Yet there's hope. The rise and enhancement of nuclear power offers a cleaner, more efficient energy source, reducing our reliance on inefficient energy production methods. It presents a potential solution to meet the growing power demands from cutting-edge data centers. And as well as the promise of nuclear fusion, which holds the key to limitless, clean energy, potentially neutralizing the strain of inefficient code on our planet's resources. An interesting article backed by research titled "How Much Energy Will AI Really Consume?" by Sophia Chen from nature.com. We investigate into the energy demands of artificial intelligence. The article reveals informative insights into the power consumption of AI computation, emphasizing the need for efficient solutions. A compelling chart is provided in the article, which illustrates the energy consumption of various AI computation tasks. For instance, when AI is requested to generate a text prompt response, it requires approximately 288 watt-hours to perform the service. However, when AI is requested to generate an image, the energy demand surges to approximately 519 watt-hours. To put this into perspective, fully charging a smartphone requires only about 22 watt-hours. This gives an interesting brief idea how much power AI consumes. In the heart of digital revolution, data centers stand as the invisible heroes, powering the vast computations that drive our modern world. These technological fortresses are backbone of big data, enabling industries to make informed decisions and deliver quality services we greatly need. Yet the great computational power comes significant energy consumption. Large-scale computations demand substantial energy, contributing to rise costs and environmental concerns. For professional industries, the challenge lies in balancing performance with sustainability. Low-level languages such as C and C++ emerge as critical players in this landscape. Their proximity to machine code offers unparalleled performance and energy efficiency, making them ideal for optimizing computations in data centers. As industries strive for the best outcomes in quality, service, and cost performance, the choice of programming language becomes a strategic decision. Understanding the primary concerns and factors in low-level languages is essential for navigating the complexities of modern computational needs. In a compelling, peer-reviewed study published by Springer Publishing House titled Programming Languages Ranking Based on Energy Measurements, scholars delve into the energy efficiency of various programming languages. Their findings shed light on the critical role of language choice in efficient software development. The research reveals that low-level languages such as C and C++ outperforms their high-level counterparts in both energy efficiency and computational performance. These languages, closer to the machine code, offer high performance with minimal energy consumption, making them ideal for cost-performance programming practices. As highlighted in the research discussing about information communication technology, consequently, to achieve energy-efficient ICT systems, it's essential to optimize not only their hardware components, but also their software components. The paper further emphasizes, therefore, given the potential importance of making informed decisions when selecting the most suitable programming languages in each context from an energy efficiency perspective. Their study illustrates comprehensive benchmarking how low-level languages such as C and C++ consumes the least amount of energy when compared to other programming languages such as Java and Python. Here we see that C and C++ took the least amount of global mean time to complete programmed computation tasks, as well as consuming least amount of energy. The units are shown in seconds for time and joules for energy. The choice of programming language is not just simply a technical decision. It is deeply connected with personal preferences and psychological factors. Each developer brings unique insights and biases to their work, shaping the digital landscape in subjective ways. We have seen that choosing efficient programming languages like C and C++ can greatly outperform slower ones like Python. However, these factors are often overlooked in the industry. Education plays an indispensable role for the future of efficiency. Research has shown that informing new developers about the benefits of low-level languages can promote a more productive perspective to software development. By teaching the next generation with this knowledge, we engineer a future where efficiency and performance are paramount. It is an undeniable fact that efficient programming plays a vital role in today's tech space. Companies like DeepSeek have demonstrated that optimizing AI models for maximum efficiency is key to their success. By prioritizing energy-efficient energy methods, they have not only elevated performance, but was able to use cheaper and older hardware due to sanctions. Their whispered accomplishment shook the entire industry unexpectedly. As we look to the future, the combination of personal preferences, education, and optimization will shape the future of efficient technology. Harnessing these principles will enable us to create a sustainable digital world, where innovation advances without compromising cost, performance, and sustainability, ensuring a brighter tomorrow for generations to come. Thank you for your attention. Together we can make a difference. Let's embrace sustainable practices and create a brighter future for all.